Hey, good afternoon. Welcome to class. So today we're going to have a look at the solutions of assignment 27. Okay, please get prepared to take any notes you need. And after this class, you should be able to correct them by yourself. Okay, correct any mistakes by yourself. Okay, question one, in a two-digit number, the units digit is thrice the tens digits. If 36 is added to the number, the digits interchange their place. Find the number. So, okay, you need to find the number, right? Suppose this number is xy. So what is a real quantity that this number stands for? It stands for actually 10x plus y, right? This is a real quantity that the number stands for. For example, for a number 12, this is actually the tens digit times a 10 plus the unit digits, right? 12 equals 1 by 10 plus 2. For another example, 21. 21 is actually tens digit times a 10 because it's in the position of 10, right? Plus the unit digit, which is 1. So 21 stands for the real quantity of 2 by 10 plus 1, right? So following the same principle, suppose we have a two-digit number x and xy. The quantity here is actually 10x plus y, right? Okay, so what information do we have to solve the two digits here? First of all, it tells you that the unit digits is thrice the tens digit. So that means y is 3 times x, right? Okay, so this is the first relationship we have. Next, the second piece of information is if 36 is added to the number. So that means originally this number is 10x plus y, right? If 36 added to the number, so we add a 36, then what happens? The digits interchange their place. So this digit becomes yx, right? So the real quantity of yx is actually 10y plus x, right? So that equals 10y plus x, right? Okay, so we have known these two pieces of information. So we should be able to solve x and y. Two variables, two equations. Okay. Suppose this is a regional number. Okay, so let's label these with number 1 and number 2. So we can put number 1 to number 2 to solve x and y, right? Okay. So y is 3x. So number 2 becomes 10x plus 3x plus 36 equals 10 times y is actually 30x plus x, right? Okay, so this tells you 36 equals 31x minus 13x, which is how many? $18x, right? Okay, so that means x is 2. Okay, we can solve x is 2. And let's label this with 3. And then we can put 3 into 1 to solve y. Y is thrice of x, which is 3 times 2, which is 6, right? Okay, so the conclusion is the number is xy means 26. Okay, any questions? No? Okay, let's see the next one. Question 2. Here's a fraction. If 2 is added to the numerator and denominator, it becomes 9 over 10. And if 3 is subtracted from the numerator and denominator, it becomes 4 over 5. Find this fraction. Okay, so we need to find this fraction. So let's suppose the fraction is, how about x and y? And then we need to solve the digit x and y, right? So what pieces of information do we have here? Okay, first one, if 2 is added to both the numerator and denominator, so that means x plus 2, right? Over y plus 2. It becomes 9 over 10, so it becomes 9 over 10. Okay, this is the first piece of information we have interpreted from the English expression. Next one, if 3 is subtracted from the numerator and denominator, so that means x minus 3, right? Over y minus 3, because 3 is subtracted from both of the numerator and denominator. And then this fraction becomes 4 over 5, right? Okay, so two variables, x and y, and two equations. You should be able to solve x and y here, right? Okay, so let's try to solve these system of equations. Okay, first of all, let's convert all the ratios to integers first. So the first equation, you can use cross multiplication method. Then you will get 10x plus 20 equals 9y plus 18, right? Okay, second one, 5x minus 15 equals 4y minus 12, right? Okay, again, further simplify the equation. First one becomes 10x minus 9y equals minus 2. Second one, 5x minus 4y equals 3, right? Okay, let's label this with 1, label this with 2. So next, we can try to eliminate x there. So that means we can time 2 to both sides of equation number 2 to get 10x minus 8y equals 6, right? Okay, let's call this number 3. And then we can use number 3 subtracted by equation 1. This will give you y equals 8, right? Okay, so let's call this 4. Then we can put 4 back into equation 2. And this will give us 5x minus 4 times 8 equals 3. Okay, that means 5x equals 35. So x is 7, right? Okay, so the original fraction is x over y means 7 over 8. Okay, any questions? No? All right, let's see question 3. If twice the age of son is added to the age of father, the sum is 56. But if twice the age of the father is added to the age of son, the sum is 82. Okay, so this is two pieces of information we have. And based on that, we want to find the ages of father and son. Okay, there are two variables. The first one is father's age. Second one is son's age. We do not know that, so it's better for us to use two letters to denote them. Okay, so first of all, let the father's age be X years or F years. Okay, how about F years here? F stands for father, okay? And son's age be S years. Okay, S stands for son. So first piece of information interpreted from the English expression is twice the age of son is added to the age of father. Twice the age of son means 2s plus the age of the father, F, and the sum is 56, right? This is first equation. Second, if twice the age of the father, twice the age of the father means 2f. Add it to the son's age, which is s. The sum is 82, right? Okay, so now we have two variables and two equations. Should be able to solve these two variables, right? Okay, so this time we can use substitution method. From the first equation, we can get f is actually 56 minus 2s. So let's call this number 3. Then we can put number 3 to equation 2. And this will give us twice of f, which is 56 minus 2s plus s equals 82, right? Okay, now we have one variable with one equation. We should be able to solve s here. Okay, let's expand everything here. 1, 1, 2 minus 4s plus s equals 82, right? Okay, so this means if we put all s's to the right hand side of the equation, we get 3s equals 30. Okay, so son's age, s is 10, right? Okay, let's call this 4. Then we can put 4 back into 3. And you will get f is 56 minus 10, which is, minus 20, right? Because it says twice of the son's age. So this means f is 36, right? Okay, so now we can make the conclusion. Father is 36 years old. Son is 10 years old. Okay, any questions? No? Okay, let's see the next one. Question 4. Flying from Toronto to Ottawa with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in still air. So there are two quantities unknown that you want to find, right? So first of all, let we use two letters to stand for the two quantities we want to know. Okay, so let W stand for or denote the speed of the wind. Okay, the unit is kilometers per hour. This is the same with the given information, right? Kilometers per hour. And next, we want the speed of the plane in still air. So next, let P denote the speed of the plane in still air. Okay, again, you need to specify the unit here, which is kilometers per hour. So, well, we have a tailwind. That means the actual travel speed is speed of the wind plus the speed of the airplane, right? So in this case, we have a W plus P. This is the actual speed. Well, when you have a headwind, that means you fly against the wind. We have P minus the wind. This is actually traveling speed, right? So according to this, first of all, if we have a tailwind, the plane averaged 158 kilometers per hour. So that means this is the speed. And in this case, the speed is W plus P, right? Okay, second, return trip, we have a headwind, right? If we have a headwind, that means the actual speed 112 is P minus W, right? Okay, so now we have a two variable, two equations. We should be able to find the value of P and W, right? Okay, so now we can use elimination method to eliminate one of the variables. We can use the first equation plus the second equation, and this will give us 2P equals 270, right? Okay, that means P is 135, okay, kilometers per hour. And let's call this 3. Then we can put 3 back into 1. This means W is 158 minus 135, which is 23 kilometers per hour. Okay, now we have the speed of the plane in the still air and the speed of the wind, right? So let's make the conclusion here. The speed of the plane in still air is 135 kilometers per hour. And the speed of the wind is 23 kilometers per hour. Okay, have a look at this question. Any questions? No. Okay, let's see the next one. Okay, question 5. A boat traveled 210 miles downstream and back. The trip downstream took 10 hours. The trip back upstream took 70 hours. What is the speed of the boat in still water? What is the speed of the current? Okay, so this problem is very similar to the previous one, right? Again, we have some speed in still water or still air. And you also want to know the speed of the current or the speed of the air, right? Okay, so let's use two letters to denote unknown quantities. Okay, the first one is a boat in the still water, right? So let B denote the speed of the boat in still water. Okay, specify the unit. Okay, unit here it uses miles and hours, right? So naturally we would use mph, which is miles per hour. Okay, next, another letter stands for the current. So let's use C. Denote the speed of the current. Okay, again, the unit is mph. All right, if you travel down the stream, that means we have an actual speed b plus c, right? And if we travel back, which is against the stream, sorry. Okay, if we travel back, suppose this is a boat. Okay, if we travel against the stream, the actual speed is both speed minus the current speed, right? Okay, so if we travel down the stream, speed times the time taken equals the total distance that we travel, right? Okay, so the speed is b plus c times the actual time taken, which is 10 hours, equals the distance we travel, which is 210, right? Okay, so this is the first relationship we have. Second, when we travel back upstream, the speed is actually b minus c. And the time taken is 70 hours. Okay, and the distance traveled is also 210, right? Okay, this makes sense, right? Because when the speed is b plus c, this is a higher speed. Higher speed, when you have a higher speed, we have less time, right? Okay, when we travel back, the speed is slower. When we have a slower speed, actually it will take you more time to finish the same trip, right? So this makes sense. Okay, now let's try to solve these equations. So first of all, we can simplify this equation. First equation, we can divide a 10 to both sides of that equation. So that means b plus c is 21, right? Second equation, we can have b minus c is 210 divided by 70 is 3, right? Okay, now this system looks simpler, right? Suppose we label them with 1 and 2. Okay, so from equation 2, we can have b is actually 3 plus c. And then let's call this 3. And then let's put 3 back into equation 1. Then you will get 3 plus c equals 21, right? And from here, you can solve 2c is 18. So that means c is 9. Right? Unit is mph. Let's call this 4. Then we can put 4 into 3 and get B is 3 plus C, which is 12 mph. Okay, so that means the speed of the boat is 12 mph and the speed of the current is 9 mph, right? Okay, so let's make the conclusion. The speed of the boat in still water, right? So I'm not gonna write it here. Actually, it's in still water. The speed of the boat is 12 mph, and the speed of the wind, the speed of the current is 9 mph. Okay. Any questions? No? All right, let's see question 6. Abigail is 6 years older than Jonathan. 6 years ago, she was twice as old as he. How old is each now? Okay, so here we want to find 2 ages of the 2 persons here, right? Okay, suppose we use some letters to denote the unknown quantities. So let J denote Jonathan's we want to find their age now, right? So let J denote Jonathan's current age. Current age. And A denote A for Abigail's current age. Okay, so what information do we have? Abigail is 6 years older than Jonathan, so that means A is J plus 6, right? That means Abigail is 6 years older than J. So 6 years ago, she was twice as old as he. So 6 years ago, Abigail is A minus 6, right? And this quantity is twice of the age of Jonathan's. Okay, so these are the 2 relationships we have. And 2 variables, 2 equations, we should be able to find the values of the 2 variables, right? So we can just put the first equation into the second equation. This will give us J plus 6 minus 6 equals 2J minus 12, right? Okay, Again, J is 12. Okay, so that means we have solved for Jonathan's current age. So let's denote this with 3. Then we can put 3 into equation 1. This will give us A is 12 plus 6, which is 18, right? Okay, so now we can make the conclusion. Jonathan is 12 years old. Now, and Abigail is 18 years old now. Okay, have a look at that. Any questions? No questions? Okay, let's see the next one. Okay, again, we have 2 persons. Wolfgang and Heinrich worked as electricians at 14 and 12 hours respectively. 1 month, Wolfgang worked 10 hours more than Heinrich. If their total income for the month was 3520, how many hours did each work during the month? Okay. Suppose we use a letter W denote the hours Wolfgang worked, and H for Heinrich. Okay, and what information do we have here? Okay, first of all, we know that W is H plus 10, right? Because it says here, Wolfgang worked 10 hours more than Heinrich. Okay, so second, we know that their total income for this month was 3520. Sorry, 20. So that means the rate of Wolfgang times the total hours he worked plus the rate for Heinrich, which is H times 12. This is a total income of Heinrich. The total income is 3520, right? Okay, so now we have 2 variables, 2 equations. We should be able to find the values of the 2 variables. Okay, we need to put the number 1 to number 2. And this will give us 14 times H plus 10 plus 12h equals 3520, right? Okay, next. 26h equals 3520 minus 140, right? So that is, okay, 3520 minus 140 is 3380, right? So now we can solve h. H is 3380 over 26, which is 130 hours. Okay, let's call this equation 3. Then we can put 3 back into equation 1 to get the value of W. W is H plus 10, which is 140. Unit is hours, right? Okay, am I correct? Okay, now we can make the conclusion. Okay. I might have marked your homework wrong. Let me check, okay? Question 7. Okay. Okay, so no problem about your markings. Do you have any questions here? No questions? All right, let's see the next one. Suppose Tom invests $5,000, part at 2% and the rest at 1.5% in interest-bearing accounts. The total yearly investment income, that is the interest, is $90. How much did Tom invest at each rate? Okay, suppose Tom invested X dollars at the rate of 2% and Y dollars at the rate of 1.5%. And actually we want to know the quantities of X and Y, right? Okay, so what information do we have? First of all, we know that total investment X plus Y is $5,000, right? Okay, second, we know that the total interest from these two parts is $90. So that means the interest from the 2% part, which is 2% of X, right? Plus the income from the second part, which is 1.5% times Y equals the total amount of interest, which is 90, right? Okay, so two variables, two equations, we should be able to find X and Y here, right? Okay, so from the first equation, we can get Y is 5,000 minus X. So let's call this 3. Again, we can put 3 into equation 2. This will give us 0.02x plus 0.015y, which is 5,000 minus x equals 90, right? Okay, let's simplify this equation. Okay, so x is 3,000, right? Okay, unit is dollars. Okay, let's call this 4. Then we can put equation 4 into equation 3. And this will get us y is 5,000 subtracted by 3,000. That means y is 2,000, right? Okay, so now let's make the conclusion. So Tom has invested $3,000 at the rate of 2% and $2,000 at the rate of 1.5%, right? Okay, any questions? No? Okay, if you have no questions, let's look at question 9. A friend bought 2 boxes of pencils and 8 notebooks for school, and it cost him $11. He went back to the same store the same day to buy school supplies for his younger brother. He spent $11.25 on 3 boxes of pencils and 5 notebooks. How much would the notebook cost? Okay, so actually we have 2 unknown quantities here, right? First, we do not know the price per box of pencils. Second, we do not know the price per notebook. Okay, so first of all, suppose we use two letters to denote these two prices. Suppose one notebook costs $N and one box of pencils costs, how about P dollars? P for pencils and N for notebooks. Okay, so first of all, we know that if we buy two boxes of pencils plus 8 notebooks, that will cost us $11, right? Okay, second, we know that if we buy 3 boxes of pencils, that is 3P, plus 5 notebooks, which is 5N, right? That will cost us $11.25, right? Okay, so these two pieces of information are interpreted from the English expression. So now we need to solve P and N based on these two equations, right? Okay, so first of all, let's simplify these equations. We can use elimination method. So in order to do that, we can time a 3 to the first equation. This will give us 6p plus 24n equals 33, right? Okay, second equation, we can time a 2 to both sides of the equation. This will give us 6p plus 10n equals 22.5, right? Okay, so let's label this with 1 and 2 respectively. Then we can use equation 1 subtracted by equation 2. And this will give us 14n equals 10.5, right? Okay, so we can solve that n is actually 0.75. So actually, here we have solved the price of notebook, right? So you can stop here. Or if you want to know the price per box of pencils as well, you can just put 3 into 1 or 2, right? So let's put it in 1. So this will give us 2p plus 8 times 0.75 equals 11. Okay, so from here we can solve the value of p. P is actually $2.5. Okay. Okay, so now we can make the conclusion. The price per one notebook is $0.75. Okay, have a look at this. Any questions here? Okay, if you have no questions, let's have a look at the next one. Some friends went to the local movie theater and bought 4 buckets of large popcorn and 6 boxes of candies. The total for the snacks was $46.5. The last time you were at the theater, you bought a large popcorn and a box of candy, and total was $9.75. How much would 2 large buckets of popcorn and 3 boxes of candy cost? Okay, so here we want to find the total price of 2 large buckets of popcorn and 3 boxes of candy cost. Well, if you know the unit price per bucket popcorn and the unit price of a box of candy, it's easy to solve the total price, right? So first of all, it's better to solve the unit price first. So again, we use 2 letters to denote unit price. Okay, suppose we use P for popcorn. Okay, so let me use P represent the cost of 1 large box. It uses buckets, right? So 1 large bucket of popcorn. And candies we use C. Let C and C represent the cost of 1 box of candy. Okay, again, we need to specify the unit. Both units uses dollars. Okay, all right, so what information do we have? So pay special attention to the sentences containing numbers. So 4 buckets of large popcorn and 6 boxes of candies. So 4P plus 6C. The total cost is 46.450, right? Okay, this is the first piece of information. Next, if we buy 1 large popcorn and 1 box of candy, so that means 1P plus 1C equals 9.75, right? Okay, and now we want to solve the value of P and C. We can start from the second equation. Second equation gives us P equals 9.75 minus C. So let's call this 3. So then let's put 3 into 1. This will give us 4 times P, which is 9.75 minus C, plus 6C equals 46.50, right? Okay, from here we can solve the C, right? Okay, 39 minus 4C plus 6C equals 46.5. Okay, so 2C equals 7.5. That means C is 3.75, right? Okay, let's label this with 4. Then we can put equation 4 into equation 3. And this will give us P is 9.75 minus 3.75, which is 6. Okay, again, do not forget to specify the unit. Okay, now we know that unit price of popcorn and candy, right? But the question asks us 2 large buckets of popcorn. That means 2P plus 3 candies, 3C, right? So 2P plus 3C is twice of 6 plus 3 times of 3.75. And this is $23.25. This is the quantity you're looking for, right? So now we can make the conclusion. Two large buckets of popcorn and 3 boxes of candy cost $23.25. Okay. Any questions? No questions? Okay, let's see question 11. The number of boys and girls in a class are in a ratio of 7 to 5. The number of boys is 8 more than the number of girls. How many boys and girls are there in this class, respectively? Okay, so the 2 unknown quantities that we want to know is number of boys and girls. Okay, so first of all, suppose we use 2 letters to denote the number of girls and boys, right? Suppose there are B boys and G girls in this class. So what information do we have here? First of all, we know the ratios of B and G, right? B to G. We can either use this sign as well, right? B to G is 7 to 5. Next, we know that number of boys is 8 more than the number of girls. So B is G plus 8, right? Okay, again, two variables, two equations. We should be able to find B and G, right? Okay, so let's start from the second equation. You can put the second equation into the first one and get G plus 8 over G equals 7 to 5, right? Okay, so now we can use cross multiplication method. That means 5G plus 50 equals 7G, right? Okay, and 2G equals 40. And finally, we can find G is 20. So that means 20 girls, right? Okay, so let's call this 3. And then we can put 3 into the second equation to find number of boys is G plus 8, which is 28, right? Okay, so now we can make the conclusion. There are 28 boys and 20 girls, right? Okay. Any questions? No? You can follow me, right? Okay, let's see the next one. The organizers of an essay competition decide that a winner in the competition gets a prize of $100 and a participant who does not win gets a prize of $25. The total prize money distributed is $3,000. Find the number of winners if the total number of participants is 63. All right, so in this competition, we have some number of people who wins, right? And the rest of the people are non-winners. Okay, so let's use two letters to denote the two types of participants. Okay, suppose there are W winners. W is a quantity, right? And N for non-winners. W winners and N non-winners. Sorry, winners, not winters. Okay, so what relationships can we interpret from the English sentences? First of all, we know that total number of participants is 63, right? So that means W plus N equals 63, right? Okay. Next, we know that the winners get a prize of 100. So that means 100W is the total prize that the winners can get. And the non-winners get a prize of 25 each. So 25 multiplied by the number of non-winners. This is the total prize win by the non-winners. This number equals the total money distributed, which is 3,000, right? Okay, so you can see here we have two variables and two equations. We should be able to find the quantity of each, right? So all you need to do is to put equation 1 to equation 2. And suppose here we want to substitute W with N. So that means 100. Sorry, we need to substitute N with W, right? So 100W plus 25N. N is 63 minus W, right? Because we want to find the quantity of W. So it's better to eliminate all the N's there. Okay, so this means 75W is 3,000 minus 25 times 63, right? Okay, so this is 3,000 time subtracted by, okay, here we use a little trick. I don't want to calculate it manually, so let's use a calculator here. 575. Okay, so 75W equals 1425. That means W is 19, right? Okay, let's check if this is the correct number. Okay, 19 it is. So here actually the solution is over, right? Because we only want to find the number of winners. So you don't have to solve the number of N, okay? So here we can directly make the conclusion. The number of winners is 19. Okay, have a look at this. Any questions? No questions? Okay, let's see the next one. A class of 195 students went on a field trip. They took 19 vehicles, some cars and some buses. If each car holds 5 students and each bus holds 25 students, how many buses did they use? Okay, so we don't know the number of buses used and the number of cars used, right? So suppose we use two letters to denote these two quantities. Suppose they take B buses and cars, C cars, right? Okay, so B stands for buses and C for cars. First of all, we do know that number of buses plus the number of cars equals the total number of vehicles used, which is 19, right? This is first information. Second, we know that the total number of students from the buses plus the total number of students from the cars is 195, right? So that means 25 per bus times the number of buses plus 5 per car times the number of cars equals total number of students, 195, right? Okay, so again, you can see that we have two variables with two equations. It's not very difficult to find the values of B and C, right? Okay, suppose we put equation 1 to equation 2. Okay, this time we want to know the number of buses they take. So we can substitute all C with B, right? Okay, so this will give us, okay, I'll write one more step here. From 1, we can get C is 19 plus B, right? So let's call this 3. And we can put 3 to 2 to get 25 buses plus 5C, which is 19 minus B equals 195, right? Okay, again, one more step. 25 B minus 5B equals 195 minus 95, right? So that means 20B equals 100. Okay, so that means B is 5, right? Are we done here? I think we are, right? Because it only asks the number of buses. So you don't have to solve the value of C. Okay, so now we can make the conclusion. They take 5 buses. Okay, have a look at this. Any questions? No questions? Okay, let's see the last one. Question 14. The sum of the digits of a certain two-digit number is 7. Reversing its digits increase the number by 9. What is this number? Okay, so suppose this number is xy. Suppose this number literally is xy, okay? So first of all, we know that sum of the two digits of a certain, the sum of two digits, which is x plus y, right, is 7. Okay, this is actually not a proper sentence. We should make it more accurate. So suppose the 10th digit is x. The unit digits is y. Okay, this is a more accurate expression. So we know that x plus y is 7, right? If we reversing its digits, the number increased by 9. So that means the original number is 10x plus y, right? Originally, this is a quantity of this number. If we reverse it, that means the new number is 10y plus x, right? So which is larger? This one is larger, right? So this one subtracted by 9 is the original number, right? Understand? Okay, so we have two variables with two equations. It's not very easy. It's not very difficult to find the solutions of x and y, right? Okay, so first equation tells us x is 7 minus y, right? So let's call this number 3. Okay, equation 2 tells us that 9x minus 9y equals minus 9, right? Okay, so further simplified to x minus y is minus 1. So let's call this 4. So if we put 3 into 4, we will get 7 minus y is minus 1. Okay, so that means 2y equals 8. So y is 4, right? Okay, let's call this 5. Again, let's put 5 back into 3. And x is 7 minus 4, which is 3, right? Okay, so that means 10th digit is x, unit digits is y. So the original number is how many? 34, right? Okay, if you would like to verify, you can verify if this is your correct solution. Okay, 34, if you reverse it, you will get 43, right? 43 is 9 plus the original number. So the second condition is satisfied. First condition is the sum of the two digits is 7. So 3 plus 4 is 7, okay? So this indeed is a correct solution. Okay, so have a look at these questions. Do you have any questions? Okay, before you leave, I need to mention that because both of you have made some mistakes or left some questions blank. So this time, I should make sure that you correct it by yourself after class. So please submit your corrections as well in your next assignment, right? Okay, you can either submit it to the Google Classroom or send a copy of your corrections to my emails, okay? Do you understand? Okay, thank you very much. So I'll upload the teacher's notes to Google Classroom and the new assignment before today's dinner time, okay? You can download it probably a couple of hours later, okay? Okay, if you have no questions, you can leave the class and have a nice weekend.